Hey guys, my name is Sandeep Patel. I'm a founder of Slotify.ca. This is my second video regarding the data structure. So in this video, we're going to learn about data structure in depth. So the topics that I'm going to be covering in this videos are what is the data, what is a data structure, what are the different types of data, how they are stored in the computer memory, and what should we know about the data types when working with them, right? So let's start with the data first. All right. So data is basically unorganized and raw, right? Data structure are a way to organize this raw data so that we can access and modify them in a really easy manner, right? You can find the data and data structure in real life. Let's take an example. So let's say we're building a Lego, right? So this single piece of Lego is a raw data, right? So when you combine this single pieces and create a block, right? So that block represent a data structure, right? So this is how you can visualize data and data structure. Let's take another example, right? Let's say that you want to build a house, right? To build a house, you need a brick, right? So brick is a single raw data that you need in order to build the house, right? So let's say you are combining multiple bricks to create a structure of brick, right? So that structure represent a data structure, right? Which uses individual bricks to create the structure, so that we can easily organize into walls, right? Um, you can also think about another example. Let's say that in your home you have a closet, right? So in your closet you have unorganized things. For example, you have clothes, socks, shoes, etc. Right? So they're all unorganized, right? And you want to organize them, so you use a data structure. For example, you use hanger to organize clothes, right? You can use shoe racks to organize your shoes, right? You can use drawers to organize a little small things like scissors, tape, and things like that, right? So basically, that is about data and data structure. Okay, let's move on. All right. So next topic is learning about different data types, right? So we'll take the same example here. So in Lego sets, you have a different type of pieces, right? You have bricks, you have plates, you have tiles, you have slopes, etc. So similarly in a programming, we have a different data types that determines what kind of data we're working with and what operation we can perform on it, right? So first type of data is called primitive data type. They're like single Lego piece, right? They are basic building blocks, right? So primitive data types includes Boolean, number, string, nulls, undefined symbols, and there is a structured data type, which we call a non-primitive data type. They're basically an object, right? For example, arrays, object, stack, queues, tree, graphs, date, regular expression, functions, classes. Let's take an example. Let's take a look at an example. All right, so in JavaScript or TypeScript, you can define primitive data type like this, right? So you have primitive means single value. The data types contain single values. So for example, you have a variable called user ID, which is a number where you can only store a single data, right? One at a time. So if you want to store a user ID 2001, you basically discard the 1001 and replace it with 2001, right? So that's a single value data type. Now you have non-primitive, which are complex object. You can think of as a complex data, right? So for example, there's a data object here. You can see an array of string. You can see a set. There's an object that contains multiple primitive types. There's also a map for user session, and that is create function. All right, so let's take a look at this code. So I have non-primitive data types defined it here, and then sorry, this is non-primitive data types, that is a primitive data types defined it here. And I'm doing a console log on the non-primitive data types just to see, just to demonstrate that non-primitive data types are object, right? For example, if I run this code, you can see that the first current date, right? So date is a type of object. You can see user roles, which is an array of string, which is also an object. User preference is already an object. User session is also an object. So greet user function are a special type of object in JavaScript or TypeScript, right? And classes are a special type of functions, right? So when you do a type of greet user, which is a function, it will represent a function. And when you use a class and run a type of, then it is also a special type of function. But when you initialize a class and then run type of, that it becomes an object, right? So you have to remember that the primitive data types, right, they're individual types. For example, if I print type of user ID, right, then you'll see that it's a type of number, right? It's a type of number, right? If I type null if I print type of null value, then it is a null. Null are object, right? And if I go undefined, this is I think also a special undefined type, right? Yeah, that's it. Let's move on. Okay. So next we're gonna look at the data structure, right? So data structure are the way to organize and store data so that it can be easily accessed and modified. If you still don't understand what the data structure is, do not worry about that. We're gonna look at in depth. All right. So now let's imagine that you want to build a Lego city, right? You need a way to organize all your pieces to build a complex structure, right? So you have individual pieces, and using those individual pieces you want to build a structure, right? So as we said before, individual pieces, they are raw data, right? So they are data, you can call them as a primitive data, and then the structure that you are building using those little individual pieces, and you build the structure, they are considered as a data structures, right? Because you're using primitives to build a complex data structure, right? All right, so there are different type of data structure. So let's learn about them. So if you look at this, if you look at this graph, this data structure, so there are majorly two types of data structure: linear and non-linear. And linear has a two types. There is a static size, which means, let's say you created array of phi, which means the size phi is a fixed size, right? You cannot change. But then there's a dynamic size where you don't define the size and it will automatically grow, right? So in static size, the arrays are considered as a static size linear data structure. In dynamic size, there are queues, stacks, and linked list. Data structures, the second type is non-linear, which includes tree and graphs. And as we know that the data structure are actually the blocks that we build using those primitives, right? I mean the single blocks in Lego, right? All right, let's go on. Okay, now let's learn about linear versus non-linear in depth. So what is linear data structure? So linear data structure means that in a linear data structure, elements are arranged sequentially, right? For example, this is an example of array where elements are like close to each other, right? So 1, 2, 3, 4, 5. You could have any value in here, but like they are in the same, they're in a contiguous memory, right? For example, this is 0 index, this is 1, this is 2, 3, 4, and so on, right? Similarly, linked list, in linked list, one node points to the other node, right? And in the sequential order. So that's about the linear data structure. In non-linear data structure, elements are not organized sequentially, right? So they don't follow the sequence, but they follow the hierarchy or network-like structure. For example, this is a tree example, right? So tree has, so this is a node. In tree, each there's a node, and this is a child node, and this is a parent node, right? And this is a example of graph. So graph is like a network type of data structure. All right, let's move on. All right, so this is very important. It is very crucial to understand how this data is stored in a computer's memory, right? So let's learn about how this is done. So we'll understand at a very high level how these data types are stored in computer's memory, right? So when computer runs a program, for example, let's consider that this is a program that we wrote, right? Which has some declaration of primitive or non-primitive data, right? So when you declare when this program runs, it creates two types of memories. There's a stack memory and there's a heap memory. Computer always has a easy access to stack memory, and that's why it pulls value from the stack memory, right? And what is the stack memory? So stack memory, um, computer always access data from the stack memory. We store simple data here. Example, primitive data types, right? So we store primitive data types. So when you define a primitive data types, for example, let's say order number equal 1, 2, 3. So in the stack memory, there is a label called order number, which has a value 1, 2, 3. And this is very crucial. In the stack memory, primitive data types are stored by values directly, right? For example, the order number has a value directly, right? While you can also store references in the stack memory, right? For example, there's a heap memory. So in heap memory, we store non-primitive data types, or for example, complex data types, right? So single data types are stored in stack memory, and the complex data is stored in heap memory. For example, let's say take an example of array. So when you define array 1, 2, 3, right? So the elements are actually stored in a heap memory, right? But then there is an address assigned to this heap memory, and that address is stored in the stack memory, right? Because computer has easy access to stack memory, right? So using this reference, it can find the location of this array in the heap memory, right? To really understand this in depth, let's take one simple example. Let's say that there is a smart building, right? Where near the entrance you have lockers, right? So consider the lockers are stack storage, right? In locker, you can store only two things, right? You can either store a single values, in that case it's a primitive data type, or you can store a reference. For example, you can also store a key. Let me tell you what the key is, okay? So let's understand the second type of storage. So let's say this building offers a storage room, right, where you have different shelves, and each shelves you can put different size boxes, right? The box's size is dynamic, right, because we're storing complex data in heap memory, right? So the size can vary, right? And we store fixed data types in stack memory, right? So we don't know what the box size is, right, until we until we start putting stuff inside the box, and then and then we figure out, okay, we need small, medium, or large box to store specific data. So that box, let's say that this particular box has a key, right? And key, I mean a reference, right? So this is a heap memory. So in the room you have box, and box has a key, and now you decided to put that key in one of these locker, right? So you go and then grab one of the locker and you put the key inside, right? So let's consider this as a reference, right? So this is a reference. For example, when you define this non-primitive data type 1, 2, 3, so this 1, 2, 3 is example of this box, right? So consider this box has a value 1, 2, 3, right? and then you lock this box using a key. So that key, then you go in the locker and store. So the locker is what? Stack memory, right? So in this stack memory, you are storing what? Reference, for example, key. And using that key, you can easily find the location of this array, right? So once you have the key, you can easily go into this room and unlock that box and find 1, 2, 3 inside, right? So that is how data stored in the computer's memory, and this is really crucial to understand, that in the stack memory, primitive data type are stored as a values, while a non-primitive data type are stored as a reference. Let's understand this practically so that you don't forget. All right, let's take one example here. Okay, so I'm going to define one primitive data, and I also define one let's say non-primitive data type. All right, so let's look at this user ID and also look at the user roles, right? Okay, so when I console log this, I see 1001 in user ID, and then admin, editor, subscriber from non-primitive data types, which is array of strings, right? All right, so what I want to demonstrate here is that how this primitive data type is stored as a value in the memory. Okay, so let's create another variable. Let's create order ID, and okay, which is a copy of user ID, right? So we made a copy. Okay, so now we made a copy of user ID, right? But we know that the user ID is stored in the stack memory as what? In stack memory as a label, and the label being user ID, and label has a value of 1001, right? Okay, so once we create a variable like the primitive data type in the stack memory, it is unmutable, right? You cannot change the value of 1001. The only way you can change is you can discard completely, right? Okay, let's print the user order ID. Okay, so when we run this, we got 1001 and 1001, right? Why? Because we make a copy. When you make a copy, you are basically going to the stack memory and grabbing what's in the stack memory. And because in the stack memory we store directly values for primitive data types, you got the value 1001, right? I think it's really simple to understand, right? Okay, so what happens when you compare this variables, right? User ID triple equals order ID. Okay, what happens? Let's run. So it returns true. Why it's true? Because user ID and order ID, when you compare, so this comparison happen at stack level, right? Stack memory level. So what is in the stack memory for user ID and order ID, right? So in stack memory, there's a label called user ID, which has value 1001, and there's another variable in the stack memory called order ID, which has a value of 1001, which is a copy of the original variable, right? It's not the same value, right? It's a different value. For example, if I change the order ID here to be, let's say, 2001, this will not affect user ID, right? This should not affect user ID. Why? Because it's a copy, right? All right, so now the comparison is false, and the order ID is changed to 2001, right? Which has two different values. Okay, now take a close look at what happens in case of non-primitive data types. Okay, so let's create another variable called user roles 2, right? Which is a copy of user roles. Let's do the same thing here. So we put we're gonna print user roles. We are gonna also print user roles 2, and then we're comparing user roles to user roles 2, and this comparison happens at stack level, right? Stack level memory. All right, so we got the same values here, right? and also returns true. But now let's see what happens. So when I change user roles to, right, and let's say I want to modify element 0, right? So instead of admin I would say um, accountant. Okay, and see what happens, right? So we change only user roles too, we did not change the user roles, right? And see what happens when you run this. It changed the values in user roles. It also changed the value in user roles too. Okay, why did this happen, right? So there's an important concept here that when you copy non-primitive data type, right, the non-primitive data type are stored as a reference, right? So these values are actually stored in a heap memory, right? But this actual label is stored in what? Stack memory. So in stack memory, what do you have? A label which is pointing to reference, and that reference and actual values are where? In heap memory, right? So when we copy, we're basically copying the reference, and that's the reason why this comparison is also true even though their values are different, right? um, we modified the value here, right? But because it's pointed to the same reference, let's say if I create another variable, let's say user roles 3, right? And even if I define the same values, right, so it's the same value, and if I compare this with user role 3 to user role 2, even though both has the same value, this is going to return false, right? And the reason why it's returning false is because in stack memory it's trying to compare reference 1 with reference 2, right? Right? And because those are two different memory address, um, it's returning false. So I hope you understand the important concept here. So in stack memory, you can store two type of values, like simple data, which is what? Primitive data, and you can also store reference, which points to heap memory, right, for non-primitive data, right? This is a really important concept. I hope this video helped you understand a really important concept of data structure. In the next video, we're gonna learn different data structures step by step. I'm gonna be starting array tutorials based on the array data structure, and I'm gonna be teaching you in real depth about how this array data structure works in real. Thanks for watching my video, and please subscribe and like my videos. Thank you.